Welcome to Stuff You Should Know, a production of iHeartRadio.
Hey, and welcome to this podcast. I'm Josh, and there's Chuck, and Jerry's here too. Did I flub that line? Yes. Am I going to retake it? No, I am not.
Welcome to the pod broadcast.
This is Stuff You Should Know, by the way. The Far Out edition.
That's right. It's in stuff out there in space.
Yeah, and not just stuff in general. We're actually going to zero in on one specific piece of stuff that's out there in space, a little planet called Saturn.
That's right. The ringed beauty, as they like to say in the biz.
It is, yeah. That's what the astrophysicists all call it. Or Saturn does have rings. It's not the only planet with rings, as we'll see. Or we can see now, I think Jupiter and Uranus and is it Mercury also that has rings? But they don't hold a candle to Saturn's rings.
Hey, get that candle away from my anus.
And, Saturn's also a really ancient planet in that as far as human experience goes, for as long as we've been looking up in the night sky, we've seen Saturn because it is the sixth planet from the sun. It's also the furthest planet away that you can see with the naked eye here on planet Earth.
You want to know something funny before we go any further?
Yeah, always.
Before we recorded, Emily was asking, as she sometimes does, what we're recording. And I told her the 2 episodes, and she asked about Saturn, and I was like, not very interesting to me. And she said, so what do you do in those episodes? Just like do commentary and make jokes? I went, well, there's probably not going to be a lot of jokes. And she said, well, as long as you can make one about Uranus. And I said, I don't think I'll be able to because it's about Saturn. And lo and behold, a minute and 20 in.
Yeah.
Wow.
Now you have 2 more times to bring it back, and then you'll have completed the comedy trifecta.
No, I think that's a oneer, as they say. But I'm just excited to report back to Emily that happened unexpectedly and delightedly.
Well, way to go, Chuck. I thought you said it was going to be funny, though.
Huh? Hey, you laughed. Was that pity?
Let's just move on.
All right, great.
Like I said, people have known about Saturn for a very, very long time. And in fact, I think 2,500 years ago, the first people to document it were the Sumerians. And not too long after that, or around that time, in India, the world's oldest astronomy book, the Surya Siddhanta, obviously, whoever wrote it was like, I'm going to try to guess the diameter of Saturn. And I don't think they guessed at it like, how many jelly beans are in this jar kind of guess. Like they used math and geometry and all sorts of great stuff.
Sure.
But this is long before they should have. So what makes it impressive is that they were only off by 1,000 miles. So today we believe that the diameter of Saturn is about 74,580 miles. In the Surya Siddhanta, they guessed 73,000 or estimated 73,580. That, my friend, is remarkable.
Yeah, regular Lewis and or Clark.
Kind of.
Weren't they famous for like almost guessing the distance?
Oh, yes. Yeah, great analogy. Sorry. It was lost on me at first.
So the name itself, Saturn, is named after Saturnus, which is the god of agriculture and harvest. So it came from the Romans. Mm-hmm. And, Saturn goes pretty slowly across the sky. So the day Saturday is named for Saturn, which is the last day of the week.
Yeah.
And now we're going to compare Saturn to Earth in a lot of scintillating ways. And we could start with just the massive size, because it makes Earth look like just a pea in a pocket, basically.
It makes it look like a nickel if Saturn was a volleyball. NASA loves that one. If you ever look up Saturn's size, NASA uses that every chance they get.
I wonder if when they got the nickel part and they were like, all right, well, we got to find something laying around here that's as big as this distance. And some guy was like, there was one sporty guy in the corner, like practicing setting a volleyball spike. Mm-hmm. He said, what about Jim over there?
Is that low-hanging fruit Phil who is about to do that?
Oh, man, poor Phil. But, you're right. Nickel compared to a volleyball is pretty good. But let's talk equator. The equator is close to 10 times larger than Earth at 227 miles around compared to Earth's piddly little 25,000 miles.
Yeah, it's got an extra spare tire compared to Earth's,
Totally.
One of the things about Saturn, though, if you aren't like a astronomy type, the kind of planet that Saturn is a gas giant, which means that it's made largely of gas, or gases. So to be a gas giant, you don't have to just be a big ball of gas, but you're made of things that typically are considered gases on the periodic table. Let's just get that straight right out of the gate, okay?
Right.
But if you put the whole thing together, Saturn doesn't have a surface to speak of. If you did go far enough in toward the center, you might eventually hit something you could stand on, but you would be under so much heat and pressure that you wouldn't be thinking about standing on the surface anymore. You'd have other problems. Yeah,
it's a very not dense planet, and some say could even float in water if there was water that large.
A pool.
Yeah, or I don't know, a pond.
Sure. Isn't that what they call lakes up in the Northeast?
I don't know the difference between a pond and a lake.
In Maine, there is no difference.
I would think a pond is human-made, but there are many human-made lakes too. So I don't know. I'll have to look that up.
I always assumed it was size. Like pond is smaller, lake is larger.
Well,
that's what that's how you remember. Lake, L, large. L.
And pond, puny.
Nice one.
That seems obvious, but surely there's something else. But maybe not. We'll look into that.
Okay.
More to come on ponds and lakes.
Okay, I'll keep talking while you look it up.
I was going to talk, so why don't you look it up? Earth is the third planet out, as Modest Mouse will tell you. They're about 92 million miles away, or we are, rather. Saturn is the sixth planet away from the sun. And things really pick up after you get away from Earth. 886 million miles, which is going to mean they're going to be a very cold planet because they get not nearly as much sun. They get about 1.2% of the sunlight that we get, which means the average temperature in the upper atmosphere of Saturn is a very chilly negative 220 degrees Fahrenheit.
Or negative 140 Celsius for our non-American, Liberian, or I can't remember the third one, friends.
That's right.
So there's some other interesting things that happen because it gets such little sunlight. But one of the things that astronomers were surprised by at first was Saturn's atmosphere. That is very cold, but it's not nearly as cold as you would expect for how far away from the sun it is and how little sunlight it gets. And they finally figured out the reason why is because Saturn generates its own internal heat. That's why it's not as cold as it should be.
That's like me.
Yeah, exactly. You could never be cold if you tried, man.
I've been cold, but and when I get cold, I have a very hard time warming up.
I meant in like the figurative sense, like
like a cold, emotional individual.
Yes.
Oh, well, thank you.
So there's a couple other things about being that far away from the sun. I think it takes 80 minutes for sunlight to get there. That's a long time to stand around and wait for sunlight. We only have to wait like 8 minutes here on Earth.
Yeah. So when they flick that switch on, you just got to sit. You got to hunker down.
Right. And then so in its orbit around the sun, it takes almost 30 Earth years for Saturn to complete a year.
Yeah, because, they're rotating very, very quickly on its axis. Second fastest in the solar system, second just behind Jupiter. But if you're talking rotation speed, here on Earth, we're going at about 978 miles an hour. Saturn is, 23,000 miles an hour.
Yeah. More than 23 times faster than Earth.
And that's going to give it a short day, about a 10.7 hour day.
Yes. And here on Earth, for comparison, a day is more than 20 hours long.
That's right.
So I said earlier, Chuck, that Saturn's a gas giant. And the two gases that it's most fond of are hydrogen and helium. Mm-hmm. And overall, I think the composition of its atmosphere is about 3/4 hydrogen, 1/4 helium. But in the planet itself, it has far less hydrogen than helium. That's about all you really need to know about those two for now. But the point of the whole thing is that there is an atmosphere. There are different layers, and the atmosphere itself is about 37 miles thick. And it is just generally gas, but it's also super freaky, as we'll see. But if we zoom in a little further, drop down a little further into Saturn, into its center, and we make it through the 37-mile thick atmosphere, we're suddenly going to find out that the pressure is extraordinarily great in the next layer, which is a layer of liquid hydrogen.
Yeah, and it's liquid hydrogen because of that pressure. It's just such a massive planet that here on Earth, if we want to make liquid hydrogen, you have to cool that gas down to very, very low temperatures, like negative 423 degrees Fahrenheit. But it's just the pressure on Saturn, even though those are high temperatures, that pressure alone can make that gas a liquid, which is incredible.
It really is. And then it gets even crazier because so further in toward the core, toward the center of the planet, that liquid hydrogen turns into a completely different kind of thing that they call liquid metallic hydrogen. It's still, again, on the periodic table of gas, even though it's in liquid form, but it behaves like a metal in that it can conduct electricity. So imagine hydrogen gas conducting electricity. And once you put your head back together, because it got blown so wide open from that, you will understand now how heat is generated inside Saturn. It's from that liquid metallic hydrogen just acting like it ain't supposed to. The reason why is because it's so compressed from the pressure toward the center that everything, even the electrons, you remember, like, electrons are, they are to like a nucleus of an atom what, I think the outer planets in our solar system is to the sun. They're really far away from it. Mm-hmm. This pressure is so great in Saturn's center that their electrons are touching. It's all mushed together, and that's why it's behaving weirdly, because the electrons can conduct electricity a lot more easily.
And then, if you want to go further down to the core, you talk about hot. We don't know for sure because you can't get in there. They've tried. They've tried. But the current belief right now is that it's basically compressed molten iron into a ball about the size of 55 Earths and a temperature of about 15,000 degrees Fahrenheit.
Which is hotter than the surface of the sun.
Hot stuff in there.
But if we're going to compare core to core, the core of the sun is 27 million degrees Fahrenheit, not 15,000,
Yeah.
I saw one other thing about the core of Saturn, and then maybe we'll take a break. Apparently, some researchers have concluded that it's actually slushy, so it's not solid, which makes sense. I mean, you'd think it'd be kind of molten or in some weird state, but that it's also made of, in addition to iron, ice, rock, and gas. And how there could possibly be ice in a core that's 15,000 degrees Fahrenheit is totally beyond me. I couldn't see a good explanation of this whatsoever. It's possible that the researchers who've proposed this completely off their rockers. I don't know. But I thought it was worth mentioning because I think that's fantastic if it is true. And hopefully there's a Stuff You Should Know listener who is out there is like, Glavin, I'm going to email in and explain to Josh and Chuck how there could possibly be ice there.
That would be great.
Yep. Okay, you want to take that heretofore promised break?
Yeah, let's do it. And we'll be back on, I don't know, let's talk about like how Saturn was formed to begin with right after this. All right, so there are a couple of theories about how Saturn was formed. If you're a regular human walking around planet Earth, you might hear both of these and say, "Sounds like you're kind of talking about basically the same thing."
Yeah.
If you're an astrophysicist, you might Glavin out, as you mentioned before. Mm-hmm. That's two Glavins, and say, "Oh, no. It is a very polarizing question in astrophysics, and to us, this difference is very large. So if you're an astrophysicist out there, this might really excite you. If you're not, I would urge you to try and be delighted in the minutia of the difference of science and how important that can be.
The question about how Saturn or gas giants like Saturn form is more polarizing than the proposal to rename Uranus.
Right.
If we work together, that's two.
That's two.
So I'm going to explain the difference because I find this fascinating. There's the main generally accepted model of how planets form, including gas giants like Saturn, is called the core accretion model. And that is basically when a star forms, like our sun, it forms out of dust and gas and all sorts of crazy stuff. And there's a lot of other debris that starts swirling around it, forming a disk. And that's where planets form from. There's all sorts of collisions and things get bigger and kind of clumped together. And as they get bigger, they attract more stuff. And the closer you are to the star, the more likely you are to attract heavy stuff, like say iron, nickel, stuff that makes up rocky planets, right? And everybody's like, core accretion model, that's just how planets form. But then there's a group of like renegade astrophysicists led by a guy named Alan Boss, who are basically like, no, that leaves a couple of questions out there. One is that there's less rocky debris in the outer reaches of this disk that's swirling around the sun. So, how can a gas giant be made out of a rocky core? And then secondly, that the remnants that are out there, say like dust and gases like hydrogen and helium, they will float away into outer space and out of the solar system and out of reach before a gas giant could form using the core accretion model. So what they've come up with instead is called the disk instability model. And they said, you don't need rocky stuff like iron and nickel to form a gas giant. It forms from gases from the start. And the core accretion model people said, okay, smart guys, how could that possibly happen? And the disk instability model people said that swirling disk becomes so compressed and so dense from swirling around the sun for so long that when it breaks up, some of that dust and gas has enough density that it can attract other dust and gases and hence form a gas giant. And the core accretion model people were agog.
I love that word, by the way.
I do too. It works really well.
Well, another remarkable thing about Saturn are the just incredible storms that happen around Saturn. There's a very large temperature difference between the very hot interlators that we were talking about. Mm-hmm. I can't remember how many degrees Fahrenheit we said, but
15,000.
Yeah, 15,000. And then the very icy upper atmosphere out there is very, very cold. Mm-hmm. Icy, obviously. Mm-hmm. And so near the equator, you're going to have winds that are going about 1,000 miles an hour. You've got a very erratic atmosphere, so it's not like it's just constantly stormy. There may be years that go between storms, but then they might go through a storm that lasts like literal years and years and years. Mm-hmm. They photographed one with the Cassini probe in 2010, and this storm was so big, and this is on a big planet, that it went all the way around and met itself like a single storm system.
Like an Ouroboros.
Yeah, that is just, we've seen some crazy storms here in recent years where from middle Mexico all the way up through like the northeast of the United States. Mm-hmm. And I'll look at a Doppler and be like, that's incredible to see a storm that large. So imagine one going all around the entire planet of Earth, and then imagine Earth size in relation to Saturn, and that'll kind of tell you how big of a storm we're talking about.
Yeah, it's absolutely nuts. And the reason why that it's got such a crazy atmosphere is because of that temperature difference, the temperature gradients. Remember we were talking about how tornadoes form on Earth and the tornado alley short stuff, that you have to have a temperature gradient? Mm-hmm. Apparently the same thing happens on Saturn as well. But there's also, Chuck, a really weird weather system that does not come and go. It's essentially a feature, it seems like, because it was first photographed in 1981 when the Voyager 2 probe did a flyby of Saturn. And when the Cassini mission arrived, I think in like 2010 9 or 10 or something like that. It saw that the exact same thing was essentially there. So what they figured out is it's not a storm. It's a really, really fast jet stream. But the thing about it, I'm sure people out there who are familiar with jet streams are like, so big whoop. Well, get this. This jet stream forms a hexagon around the top of the planet. It's one of the weirder things I've ever seen.
Yeah, it's like you said, they photographed it in 1981. And then I think the Cassini-Huygens mission ended in 2017.
Mm-hmm.
And it was still there and still basically looked the same. And I can only reckon that it's still like that today.
Yeah, I think that's a good reckon.
We're talking 500-mile-an-hour winds at the center of this vortex.
Mm-hmm.
And they think that weird shape is due to the really fast rotation, which makes a bulge at the equator and flattens things out at the pole. So it's just created this really strange kind of jet stream, this strange shape.
Yeah. So I think, Chuck, we can't really put it off any longer. I believe that it's time to talk about Saturn's rings. Because, I mean, imagine if we didn't in this episode.
Yeah, I mean, you mentioned, it's not the only one with rings. I know you mentioned my anus.
Mm-hmm.
Sorry.
That's 3.
I know. That's the lowest of low-hanging fruit, though.
Phil would be like, it's fine.
Yeah, Phil would love it. But Neptune and Jupiter, I'm not sure if you mentioned those. Those are some other ringed planets. But Saturns are those are the showstoppers. They're incredible. If you've ever, do yourself a favor. If you've never looked at real pictures, telescopic pictures of Saturn, do so, because it's incredible looking, these pictures.
I have an anecdote about that.
Let's hear it.
So remember we did an Australian tour a few years back?
It was great. Yes.
Yeah, it was. On one of the days off, Yumi and I went to the Sydney Observatory one night.
Oh, cool.
And they just happened to have one of their telescopes trained on Saturn, and you could lean over and look through the eyepiece. And we did, and both of us just started laughing because it looked so fake, like a little white cutout of Saturn, just flat as could be. It just looked like they were like, we can't find Saturn, so we're going to have to put this
put the slide in there.
Yeah, exactly. But the volunteer was looking at us like, what's so funny about Saturn, basically.
Right.
And we just moved along, but that's my Saturn anecdote.
And you said it looked fake, and he's like, "That's real, man."
No, we
Jeez.
We didn't bother to say anything. It was mine and Yumi's little joke.
That was the worst Aussie accent I've ever done, and I've done some pretty good ones over the years.
You have.
I don't know what happened.
It sounded like Billy Ray Cyrus trying to do an Australian accent.
It came out so wrong. It was very strange. It sounded better in my head right before I said it. So yeah. Aside from the telescope slide fake, it's just incredible looking, and the sort of knockout fact is we're still not exactly sure where these rings came from.
Mm-hmm. And we've known about the rings. So remember, people have known about Saturn since we started looking up at the sky, but you can't see the rings. But right when people started inventing telescopes, they noticed that Saturn had something weird going on. In 1610, Galileo, the astronomer made famous by the Indigo Girls, he spotted Saturn's rings in his telescope, but it wasn't of high enough quality for him to be like, those are rings. He thought they were like bulges on the side, like handles on a pot or something like that. He wasn't quite sure what the heck it was. He actually, I think, thought it was like a 3-body system, like 2 huge moons and a planet. And it wasn't, but I mean, 50 years later, I guess, even less, that Christian Huygens said, I've got a much better telescope now, and those are rings. I bet my bottom dollar on it. That was his famous quote.
You know what Galileo's crime was?
Loving too much?
Looking up the truth.
Is that what the lyric is?
Yeah, that's a great song.
Sure it is.
I went to the same orthodontist as Emily from Indigo Girls.
Oh, that's great.
That's my claim to fame.
Did I can't even come up with a joke, but yes, that's great.
Shout out to Dr. Blake. Hope he's still around. He may not be. This was in the 80s, and he was
okay.
And is probably, I mean, he looked 70, but that means he was probably 50.
Right, in the 80s, sure.
Yeah, and just for my teenage gaze,
I was going to say that was mean. Like, this is like
No.
recent person you went to.
No, I mean, he could still be around. He could be in his 90s probably, but
Sure.
I hope he is. I hope he's still putting braces on kids.
Yeah. They don't want him, but he's doing it anyway.
He's putting like 1980s braces on kids, though.
Right.
They've come a long way, and he's like, no, these metal bands go around your teeth.
Mm-hmm. The lip slashers.
Oh, God. All right, so back to the rings. They are 95% ice. It's rock and ice, but 95% of it is ice. And these are particles, but when you say particles, it could be a particle, like a sandy grain, but it could also be like a large boulder, like they vary widely in size. And here's the thing about those rings, too. They are very, very wide, but comparatively, they are very, very thin. I think the farthest ring, which is 175,000 miles from the upper atmosphere of Saturn, is 7,000 times the diameter of the planet, but only about 30 to 60 feet wide, or thick, I guess.
Isn't that nuts?
Yeah.
I mean, that's crazy. Like, how does that thing even exist is my question.
Well, we're about to tell you.
So if you look at Saturn, especially through a Sydney-based telescope, you're going to see that it looks like it basically like kind of cocked its rings to the side like a hat, a jaunty cap, as I put it.
Yeah, I do that sometimes with certain caps.
Exactly. Who doesn't? Everybody's familiar with that.
Yeah.
The thing is Saturn's not doing that. Actually, if you straighten Saturn out, its rings would be roughly parallel to its equator. It turns out that Saturn itself is jauntily cocked to the side, too, to the tune of 27 degrees. And Earth's axial tilt, I think is what it's called. So the tilt relative to the plane of orbit around the sun. Flat plane, tilted planet. Let's just leave it at that. Earth is 23 degrees. So 27 isn't that much more, but Saturn's rings like really point out how angled the whole thing is.
Yeah. If we had a little jaunty cap, then Earth would look jaunty as well, I guess.
Yeah, but the other thing about it too is with a axial tilt that pronounced, like Earth's and like Saturn's, that's how you have seasons. Some parts are closer to the sun at different times of the year. Same thing on Saturn, but since Saturn's years are almost 30 Earth years long, that would mean that the seasons are like 7 years long on Saturn.
Yeah.
Neat. 7-year spring. Who wouldn't want that?
Mean, that's a good band name right there.
It is. It really is, Chuck.
These rings are separated. Obviously, when you look at them, you can tell there are gaps in between, and some are brighter than others. Some are more dense than others. And because of that, they, when they noticed the rings, they didn't know about all of them. They were discovered individually over time and named A, B, C, D, E, F, and G in order of when they were found. But that's not the actual order of where they are if you just started at Saturn and worked your way out.
Right.
In that case, it would be D, C, B, A, F, G, and then E.
And the best mnemonic device I could come up to remember that is don't choose brunch and forego grits and eggs.
That's pretty good.
Yeah, I thought so too.
I thought just a nonsense joke was coming my way, but
no,
that one actually
real way you
made
could
sense. Yeah, nice work.
Yeah.
Phil approves.
Good. Thanks, Phil. So if you ever noticed Saturn's rings also, there's like dark stripes in between them. That's actually voids in between the rings, right? That Saturn's got tons of rings. Some are bigger than others. And when you kind of look at them from afar, it just looks like they have, what is that? Seven rings. But there's actually way more. These are just the rings that we can see and identify. And they're differentiated by these gaps. And there's a huge gap, I think, between the B ring and the A ring. So it's about in the middle of Saturn's rings. It's called the Cassini division. And it's about 3,000 miles across.
Yeah, and that's a big gap.
Yeah, it is a big gap. And to kind of put this in perspective, especially for our American friends, if you took Seattle and you took Boston and you erased the country in between them and replaced it with the void of space, the people in Seattle and Boston could look out from one another across what was roughly the size of the Cassini division. I like that analogy. I don't know what's so funny about it.
Daddy, how far is 3,000 miles?
Okay, but it was the replacing it with the void of space that I think really drove it home, if you ask me.
Yeah.
Do you know how
3,000
long
miles.
I went into a distance calculator to figure out two cities that most people know are roughly 3,000 miles apart?
Did you come up with that?
Yeah.
So the Cassini division, the cause of that whole thing is the interaction, gravitationally speaking, with the moon, and we'll talk about the various moons coming up.
Mhm.
But the moon, I guess, is it Mimas? It's not Mimas, is it?
I've been saying Mimas.
Yeah, I've been saying Mimas in my head.
Although Mimas makes sense too.
Yeah, but I like Mimas.
Okay.
Because it's not Teton, it's Titan.
Depending on where you live, though.
I guess so. But the particles in that B ring orbit about 2 times for each of Mimas's trip around Saturn. And each time they're going to pass, Mimas has the chance to, inflict a little gravitational influence on those particles. And that just accumulates, basically, and it creates a very steady gravitational force on those particles. It's just going to hold them right there in place, and they're not going to drift into the gap. They're going to stay nice and tight.
Yeah, that's pretty cool. That's how the Cassini division is created, by that gravitational pull. And
That's right.
Mimas also is nicknamed the Death Star, because if you look at a picture of Mimas, it looks an awful lot like the Death Star.
Yeah.
And the Death Star, that's it's like a space fortress in the Star Wars movies.
That's no planet.
That's right, but no, it's a moon.
Oh, that's no moon? Was that what it was?
No, I'm saying he was right. It isn't a planet. It's a moon.
I can't remember the line, though. Was it, that's no planet? I think that's what it was.
I'm pretty sure. Wasn't that Han Solo saying that?
Yeah, I think so. But, it's no big deal if you get Star Wars stuff wrong, right?
No, everybody's very easygoing about that stuff.
Should we break or should we not?
Let's talk about how the rings formed, and then we'll come back and talk. No, let's take a break.
You want to take a break?
Yeah.
Okay. And then we'll talk about how those rings form right after this.
So, Chuck, you said a little early on, I think, that the people who study this kind of stuff are not 100% sure how Saturn's rings formed, right?
Right.
There's a lot of different competing theories. There's a whole camp that's like they're as old as the planet. So they're multi-billion-year-old rings. And other people are like, that's just stupid. And specifically, there's a researcher from NASA who in 1986 wrote a paper. His name's Jack Connerny. I don't think he actually said, your idea is stupid to other people. But what he did do is he calculated the rate of what came to be called ring rain. And that is those particles falling into Saturn. And when they do that, that ring becomes slightly depleted. And it happens more and more and more. And on the scale of tens or hundreds of millions of years, Saturn is eventually steadily losing its rings. And apparently the particles fall into Saturn when they become charged. And I guess they're more attracted by Saturn's gravitational pull. And they travel down the magnetosphere, just like particles bombard Earth's magnetosphere and produce the auroras. Same thing happens to Saturn, but it's paying the price. It's at the expense of losing its rings.
Does it become part of Saturn itself? Does it suck that up into Saturn?
Yes, I believe so. And I think it melts as it gets further and further toward the center.
Okay, so Saturn isn't necessarily becoming larger as the rings deplete.
No, Leon's becoming larger.
Okay. So, all right, that means a lot of stuff. That means that we are living on Earth at a time where we just happen to live, and it's a long period of time, but if you zoom out on a macro level, cosmically speaking, it's not that long. But we happen to be living in a time where we're probably at like peak ring, don't you think?
Yeah, because guys like Jack Connerny calculated that based on the rate of ring rain, the rings probably aren't more than 100 million years old, right?
Yeah.
So 100 million years before this, Saturn wouldn't have had rings. And they also calculated 100 to 300 million years hence, Saturn's not going to have rings either. And the way that they came up with that 100 million year old estimate is because any older than that, there should be far less rings based on the rate of ring rain. And if it were younger, there should be more rings than that. So that group is pretty self-satisfied right now.
Yeah, I bet they are. We also talked about, well, we still haven't really talked about where the actual stuff that makes up those rings come from. And again, there are competing theories, one of which is that there used to be, and again, we'll get to the moons. Saturn has lots of moons, but one theory is that there used to have even a lot more moons than they have now. And one of those moons that may have existed, they actually named Chrysalis, was in a little bit of a push and pull with Titan, the largest moon, a gravitational battle.
Or Titan.
Or Titan, yeah. It fell out of orbit because of that battle. I guess Titan wins. And Chrysalis veered too close to Saturn, was basically just busted apart by the gravity of this enormous gas giant. Mm-hmm. And then that debris field is what formed that ring. And then over time, over millions and millions of years, Chrysalis continued to sort of crash into itself and created like the smaller rings around itself, or above and below.
And also some of the bigger ones, because, you know, like you said, some of the particles in the rings are like grain of sand size, but other like boulder size. And those boulder ones are just ones that haven't crashed into the proper other boulders yet to create those sand grains. It's just a matter of time eventually.
Yeah. What's the other theory?
There's another theory, which, by the way, Saturn apparently is like a thunderdome for astrophysicists. There's so many different theories about so many different things.
Yeah.
But the other theory is that a bunch of Saturn's moons collided together. It wasn't just one getting pulled towards Saturn. They all just kind of got all tripped up and boom, 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 boom. And all of a sudden you've got this debris field that got smaller and smaller, more particulate over time, just like the chrysalis theory too.
So they don't fight over this one probably as much.
Not as much. But they do dress like Master Blaster when they talk about it. They just don't actually fight.
Some of these rings are formed by these moons. There's one called, one of the moons, Enceladus.
I'm going with Enceladus.
Enceladus? Okay.
Enceladus sounds way too much like salad.
Yeah. Enchilada, yeah. This thing is erupting salt water kind of constantly into the atmosphere, and that turns into ice crystals. And those ice crystals, as we see, can very easily form into rings. And that is, in fact, where we get our E-ring around Saturn, if you're looking at the letters. So I guess the A, B, C, D, E, the fifth one discovered.
Well, no, remember they are out of order. Oh, yeah, the fifth one discovered. You're right. Sorry.
Yeah.
Nice save. So there's also another ring that they discovered as recently as 2009. Like, because our telescopes just keep getting better and better, from Galileo's in 1610 to the Spitzer Space Telescope. Surprisingly hard to say.
Yeah.
They found a new ring that basically follows the orbit of Saturn's furthest moon out, Phoebe, Buffet.
Yeah. That's right. I was going to say Bridgers, but sure.
Yeah. Yours is a little more art housey than mine.
I love that Boy Genius record. So good. I believe Phoebe's is a very faint ring. Is that right?
Yeah. Yeah. It's very, that's why it took so long for us to find it.
Yeah. I
think we knew Phoebe existed, the moon. It could be Phoebe. They might be pronouncing it like that. But we didn't know the ring was there until 2009.
Yeah. But the reason we're mentioning all this is the fact that those rings are, they're dynamic. They're changing, they're reshaping. And like we said, in, maybe as little as 100 million years, they may not even be there.
Yeah. I just think that's really fascinating. Yeah. You can thank the good Lord that we're alive at a time when Saturn has rings and we have telescopes.
That's right.
So we also talked a lot about the moons just now, and it turns out that Saturn's moons are really fascinating in and of themselves. It has a bunch of moons, as many as 146 that we know about right now. Mm-hmm. Just last year, 2 years ago when this comes out, in 2023, the International Astronomical Union, they added 62 more moons. And I don't know if they were saving up and just wanted to do a batch edition of moons, or
Yeah,
if they
probably
found
so.
a bunch in quick succession, I'm not sure. But there are definitely more moons there.
Yeah, more moons coming. I mean, because just a couple of years ago there were under 100. Now there's 146.
Mhm.
So big changes. So keep collecting those moons, everybody, and hit us in a few years with a number that's going to knock our socks off.
Collect all 146.
That's right.
So the other thing about the moons too is that they orbit outside of the rings, which makes sense because the
Yeah.
moons that were inside of the rings were what make up the rings, probably.
Yeah.
So these moons haven't smashed into anything else, and they're just orbiting around. And like you said, Mimas, that one exerts a gravitational influence that creates the Cassini division, which means that it's really close to those rings. It's actually the nearest moon to Saturn's atmosphere, but it's only about half the distance of the moon we have here on Earth, which is about 237,000 miles, as every Shining fan knows.
That's right. But this thing hauls. It has an orbital speed of about 32,000 miles an hour. It's so fast that it completes an orbit in less than an Earth day, about 22 hours. And if you consider our moon here on Earth, what does it take? About a month to complete its orbit. That's really cooking.
In fact, the month is based on the moon taking a month.
Yeah.
They're inextricable, basically.
So is their month 22 hours?
I guess so. Yeah.
Because what was their day? What did you say their day was?
10-ish, I think. 10.6.
Yeah, that's right. 10.
So there's a bunch of different moons, different sizes, but Saturn has some really, really big ones. Titan, which we've already talked about, is enormous. And
What a moon.
It is a great moon. Its size is large enough that it can actually hold an atmosphere in place. It's one of the very few moons that we know about that has an actual atmosphere to speak of. And boy, are we going to speak about it.
Yeah, it is. It's Titan is quite striking. It is has mountains made of ice. It has seas made of ethane and liquid methane.
Mm-hmm.
So it's just an incredible moon. It has an atmosphere much like ours. It's composed of nitrogen, but it has an air pressure that just knocks ours out of the park. It's I think 150% stronger at sea level, which is going to be like, you'd think you were on LSD or something if you plopped yourself on Titan and you would look around and you were being like, wait, there's odd things happening. Like it's raining really slowly. And someone would say, well, what does that even mean? It's like, well, look at the literal rain. It's coming down at about 3.5 miles an hour. On Earth, it rains down at about 20 miles an hour. And it sounds funny and it looks funny.
And one of the friends there was like, rain's a weird word. Have you ever thought about that word, rain?
But why does it sound funny?
Because the atmosphere is so thick that vibration sound can travel much more efficiently through it. So if you shouted like, hello, you would burst the eardrums of your friend on LSD.
Yeah. If you said, look how slow the rain is.
They just
It's
clap
all
their
over.
hands over their ears and like double over in pain.
But it's not a hospitable place. Like nothing could live on the surface of Titan. I think it has a negative 290 degree Fahrenheit average temperature. And like we said, the liquids there are methane and ethane. So that's, you can't do anything with those two.
No, but there is a liquid ocean about 50 miles below the surface, that methane and ethane and ice surface. And this ocean is actually made of salt water.
Yeah, good fishing from what I hear.
For sure. But that's the point. They're like, wait a minute, there's salt water there. It's heated by the core of Titan. There's also hydrocarbons on the planet's surface. Like, if you put this stuff together in just the right arrangement, you might have some sort of bizarre form of life. Like these are organic materials that you could conceivably create life from. So who knows what's swimming around or floating around in that ocean underneath Titan's surface.
Yeah.
That's why people are so jazzed about Titan.
Yeah, totally. And it's Titan. I mean, come on.
Yeah.
There's
also, what'd you say? Enceladus?
Enceladus.
That's right.
What'd you call it?
I said Enceladus. You said something else. It sounded like salad.
Are you?
Enceladus.
I think I said Enceladus. We'll let the listeners decide.
Have you ever thought about that word Enceladus?
What's the deal with that one? I know it's about the size of Arizona, and also has a saltwater ocean under the crust. That is.
So far, Titan's 2 for 2 that we've talked about. We've talked about 2 moons, and both of them happen to have saltwater oceans.
Yeah, underneath.
Yeah, that's a big one too. So like it's underneath its icy crust, which means that it's protected and heated so much, in fact, that I think we said Enceladus, now I don't know how to say it, bursts ice from its ocean out into the atmosphere, creating the E-ring, which is pretty cool in and of itself. But that also means that there's geysers, and where there's geysers, there's probably hydrothermal vents on the ocean floor, the floor of the saltwater ocean, and that means that life could conceivably create or start up there, because that's a really popular theory these days about how life started on Earth around hydrothermal vents in the ocean.
Yeah.
So who knows? And then the Cassini probe wrote home from camp not too long ago and was like, hey, I sampled some of this water and it's got some mind-blowing stuff in there.
Yeah, for sure. And, we mentioned earlier the Cassini spacecraft finished up in 2017. It was called the grand finale when it wrapped up its mission because it, on purpose, says like, hey, let's just get really close and just kamikaze this thing and just see what kind of readings we can get up to the last second there. So that's how it ended its mission. But there's a new one, Dragonfly, that's coming up, I believe, launching in 2028 and will arrive on Titan by 2034. So, I mean, hang on to your hats. It'll be a decade, but then we're going to start get some, imagine the changes that are going to happen between now and then. Yeah,
for sure. And there's actually a really cool animation, artist interpretation of that grand finale of the Cassini probe that's worth watching on YouTube.
Oh, cool.
You got anything else?
I got nothing else.
I got one more thing. It turns out in the Northern Hemisphere, September 2025 will be the best time to view Saturn because it'll be on the opposite side of the sun from Earth, so it'll be nice and bright and easy to see.
Oh, cool. Well, we'll either think to remind you, and we'll probably forget, but I imagine that'll be a newsmaker. Like people on the news will be saying, like, hey, go out and look for Saturn.
For sure.
Might be able to see it with your eyeballs.
Okay, well, Chuck mentioned eyeballs, so we have no choice but to unlock listener mail.
Hey, guys, this is from Rockney. I'm the mother of one. It says nother, but I bet they meant mother.
Probably.
I'm the mother of one of your longtime listeners. I don't remember exactly when I started listening, but it was back in high school. I graduated.
Wait a minute. Wait. So Rockney is the mother of one of our listeners.
Oh, no.
Rockney's okay.
I bet you anything they meant to say I'm another one of your longtime listeners.
Oh, okay.
Now that I'm reading it and doing the math.
Okay.
Here we go. Hey, guys, my name is Rockney. I'm another one of your longtime listeners.
Nice.
My girlfriend Anna has never listened to a single episode of your podcast. English is her second language, so she's probably Anna. And English spoken word entertainment doesn't quite feel relaxing for her yet, so don't hold it against her. But over the past few weeks, I've been on a mission. I've been humming, whistling, and vocalizing the Stuff You Should Know theme song nonstop around her, trying to make it familiar. And this past weekend, my experiment finally succeeded. I caught her humming it on her own, completely unprompted. I came clean, told her I'd been training her ears, explaining it's the theme song of my podcast. She's familiar with Stuff You Should Know through my constant mentions, and she just calls it my podcast. We both had a great laugh about it. Recently, I heard a listener mail from a mom who casually used Clark as a verb, so I figured I'd share my similar success story. So thanks for over 1.2 decades of entertainment, and that is from Rockney.
Thanks a lot, Rockney. We appreciate that. Thanks for trying to spread the good word by creating earworms.
That's right.
If you want to be like Rockney and let us know your situation, we love to hear that kind of stuff. You can wrap it up, spank it on the bottom, and send it off to stuffpodcast@iheartradio.com.
Stuff You Should Know is a production of iHeartRadio. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.